I haven't got the confirmation that it's started. There you go. Recording has started. Okay. So in this session, I plan to go through the changes that I've made to the monitor from a technical perspective, and also would like to discuss how we go about doing release management on GitHub. We have so many repositories now, and I think what we should be doing is we should be versioning our tools and our utilities. Certainly the monitor should have some versions. And probably over the next day or so, I'll be spending quite a lot of time or investing some time in doing documentation that will help people to run the monitor, right? And I think for that, there he's joining now. Let me just let him in. Is that better, Kutsal?
Yeah, much better. I can hear now.
Cool.
I'm outside, so there might be some background noise. I'll just mute myself.
Okay,
when I'm not
great.
talking.
Thanks.
Thanks.
So we're recording, and I'll put this up on the YouTube channel a little bit later. Right. So let me share my screen.
Just one note. I'll have to leave in half hour. I'm very sorry about that. It's a short notice. So I'd be very happy if we can have the most important stuff.
Yeah. Let's
I
try.
apologize for this.
Alrighty. Okay. So. Okay. So I think this is the third or the fourth. Anyway, I'm calling it the third tech review, and I'll go through at a high level what I've been working on, and then we can actually jump in and look at the code and do a code review, or at least a code walkthrough, not a code review. And to start with, there are a couple of challenges that we've had with the design of the monitor. Not least of all, the fact that it has many components. And if you want to run the monitor, you have to run database, you have to run a copy of Redis, you have to run a copy of the API, then you run a copy of the P2P server, and then you run the front end, which is an Nginx serving a static website, and then you run the workers, right? Or at least one worker. And that is a complication that I think will not help adoption. So I want to simplify that, and I have simplified that a lot. Okay. And then the second challenge that I had is across all of these modules, or across some of these modules, they need concurrent access to the database. That's okay. You can do that with Sequelize. But when one module has done something, for example, when the P2P server has done something, to hand it off to the API service required some changes, and that intermodular communication was missing. So as part of the design challenge, what I needed to do is I needed to put a lot of this functionality into either one component or a framework, and you'll see that I've chosen a framework for this. But I also need to keep it really lightweight, because we don't want any long-running jobs in the application layer. I'm calling this application layer, but you'll see how the design works. And we want to hand off all the heavy work to the workers, because that's what they're there for, long-running jobs. They don't block anything like that. How would you normally do this in another application? Maybe you would have multiple threads. Maybe you would actually run separate components, etc. But instead of rewriting Substrate, keeping it straightforward, just going to a design where all the light, fast stuff is done in the application layer, and all the big, heavy jobs are done by the workers. Okay. And I needed a design where the workers have enough context to do the work. They will not have access to the database, because they will have a connection. For example, they would have a connection to the chain, so they could ask the chain for something, but they can't read and write directly to the storage. So you'll see in the design that the workers now subscribe to events that happen in the application layer. The application layer raises an event and sends it to the worker, and it sends a lot of context along with that event. For example, what is the service ID? What is the member ID? What's the URL? What's the test that we want them to perform? Okay, and then the worker performs that test if it has the capabilities. So I've also introduced the concept that workers can have different capabilities, and you can subscribe for different things. Okay, so it's taken me some time to try to get to a design where everything works neatly and the design is elegant. This is some of the solutions that I've investigated. There is an NPM package called Container. And what that allows you to do is it allows you to create an instance of an object, for example, an instance of the database connection or an instance of a WebSocket, and you can pass that instance around between your modules rather than each module importing and creating its own database connection, for example. That was pretty cool. I'll just give you a quick view of this. What you do is you create this thing they call it a container, whatever. Okay. And then what you can do is you can do container.add. And here they've said, I don't know, adding some settings. You can do container.add logger. And that is a function. And then later on, you can pass this container around to your modules. And then you can just ask, I call it context because I think context is a better word, but you can ask the context. It's almost like a provider. You say, give me the database connection or give me the URL for the API server or something like that. This helped a lot where you could add all of the various modules to the container and then reuse them later. But it didn't solve the problem of having multiple components where the components needed to talk to each other. So we still had to solve that problem. Then looking for a different type of solution, I came across Nest.js microservice pattern. And the microservice pattern allows you to create application that can handle multiple protocols. Those protocols are baked in, they're included. You can handle MQTT, REST. There's a couple of, I forget, there's like 9 different protocols that you can handle. The problem was, of course, Nest.js didn't have a native handling for libp2p. So I implemented libp2p as a microservice. And what I then found is that even though it works as a microservice, it doesn't have access to the rest of the app. So the libp2p was running in a microservice, and all of the rest of the functionality was running in the normal Nest.js app. But if they had to talk to each other, I had to implement that custom. So I implemented 0MQ between the 2 components, and that actually worked really well. You can basically just hand a message to 0MQ. You can wrap it in a promise. So you can do async send, and you would get an answer back whenever the 0MQ response came back. It worked really well. The only challenge with that was I then found out that the microservice doesn't run in its own thread. So that because this is Node.js, everything runs in one thread and you have to use async as much as you can. Fine, 0MQ was running in async where possible, but because it doesn't run in a separate thread, there's really no advantage to developing a microservice pattern over using the concept that they have, which is called a gateway. And I had already implemented a WebSocket gateway to listen for WebSocket connections from the workers. So I ported I ported this libp2p connection over to the libp2p gateway, and you'll see that when we do the code walkthrough. And also what I've, just for completion here, I've implemented a WebSocket gateway. So this works really well for the workers because they connect via WebSockets and they subscribe to events that happen on the monitor. And one of those events is to run jobs. Okay. And the event has some meta that comes with it. You'll see that the event, it says run jobs. It gives you the job name and it will check to see if the worker has the capability to run that job. Currently, we've got 3 types of jobs that are implemented, but obviously this gives us a framework for implementing more jobs. Okay, and then there's just a little bit of protection here where the monitor operator will define in their config what the API key is. And in order to run a worker that connects to your monitor, that worker will need to know what the API key is. Otherwise, the connection will be rejected, just so that we don't get spammed with lots of junk connections or people tinkering in a. Okay.
Derek, may I just ask something, or should I keep it for later?
You can ask. Go ahead.
Okay. So with the message queuing and the main problem here is, I think, the communication between different modules or different like instances of programs, you'd say. So I think Redis supports publishing messages. So so I'm thinking, could we utilize that instead of introducing new things? Or, for instance, does 0MQ bring anything extra on top of that? Did we evaluate like what we have before introducing new things for communication?
Yeah, so this is what this session is for. Thanks for the question. So what's the benefit of 0MQ over things like Redis? Because they could do similar usage patterns, right? And it goes back to one of the things that I felt at the beginning was that we have too many components. And I wanted to see what can we do? Do we really need Redis? And the reason why it was implemented was because we were doing the workers based off of bool MQ queues. So I revisited that pattern, and even though I implemented 0MQ, 0MQ is serverless. It doesn't actually need another component. You just need the 2 people to listen on the same port, and hey, you've got a queue. So it's pretty cool. And it's blindingly fast. But in the end, I actually chucked it. We don't use it. We don't have a 0MQ and we don't have a Redis because I've implemented libp2p as a gateway using the gateway pattern, which I'll show you. So it's a reduction. It's a reduction in a simplification of the number of components that we're running, and also a much better modular approach where you can you'll see the way that Nest.js does it. Right, so what does the design proposal current implementation for, I'm calling it 0.2. I don't know if we were happy with the numbering. We need to talk about release management to see what numbering we go for. But 0.1 is clearly what we've got right now. Or is it 0.0.1? Don't know. Don't want to be so pessimistic. Okay, so the components are largely a Nest.js app, and the Nest.js app serves the front end via static files. So we still need to build the front end if you're gonna help or if you're gonna work on the front end. There's a separate directory for the front end where you spin up the front end server for development. You run it, etc. It will run off of the back end the same way, and then when you're finished, you do an yarn build, I think it does, and then it builds the whole front end into a dedicated directory, and it's that directory that we will serve the front end from in production mode. Okay, the API now is it's just scattered throughout all of the modules. Each of the modules, you'll see there's one for monitor, there's one for health check, there's one for service, there's one for member. Each of those modules have controller capabilities in them. So the API is now just baked into the fact that we have modules that have got controller capability. You'll see that. Okay. Inside the Nest app, we have the libp2p gateway, and it is just a technical connection between the P2P network and something called the P2P service, which is a service layer. We have a web service gateway, which is used for the workers to connect to. Okay. And I've introduced something called tasks. And I found that Nest.js did this quite elegantly. They have their own sort of like internal cron where you could schedule things. So I've introduced the concept of tasks, which is short running internal jobs. Well, not, I didn't want to call them jobs because we're using that term for workers, aren't we? So that's why I called it tasks. And these are internal, and they're not meant to be done by workers because we just don't trust the workers to do it. So we need to. It's something that we can't farm out because if the worker comes back with a wrong answer, it will mess up the database. Okay, so we've got the Nest.js app, which contains this functionality, and the database, and that's it. Those two components will run an instance of the monitor. Okay, that monitor will connect to the network and it will start receiving health check updates, etc. The next component is the worker, and you can run as many instances of this as you like. And however many workers you decide to run, they run, I say standalone, but actually they connect using, they connect to any monitor. So for example, I could run a worker that goes against or works, accepts jobs from Kutzal's monitor. But the only way that I can do that is if you share an API key with me, and then that allows the worker to participate in the workload. There are some jobs that we already know. We know that the check service job is what's currently being executed. And then there's a new one, which is called check boot node. And we can, if we have time at the end, I can go through the design for the check boot node. The only requirement here is that this job needs access to some executables on the file system in order to run, because it will actually spin up a temporary node and then try to connect to the boot nodes that way. And also these executables need to be compiled custom because they are bootless, right? They don't have any boot nodes in them, because that's what we're trying to do, is we're trying to test boot nodes. But I'll spend a bit more time on this later if we've got time. Okay, so let's have a look then at the worker design. It's really simple. Okay, it contains worker.js, which I'll show you in the code, makes a connection to a monitor and then listens to events. And then on the event happening, it will run the job that was requested. And that's going to be either check service or check boot node. There's another job called ping that I implemented just so that we could check if the worker is alive or not. Okay, and then we have inside here just a config.js, and that gives you a worker ID so that you can give it a name. Okay, this is the API key. The worker needs an API key to connect to the monitor. And then there's an array of capabilities, and the capabilities tell the main server what you can do. So if you can do check service, but you can't do check boot node, then that comes out in the capabilities and you won't be asked to check that. And then the binary directory is just a config where to find the binaries for some of the tasks that have to be done. Okay. What I haven't managed just yet, and it will be the focus as quickly as possible, we need to come up with a release management process. I posted some examples, and I think Paolo, you posted some examples as well of how we can do that. I think we do need a release management process that's probably similar to what they're using for the parity tools, like the 1KV backend or something like that, where we actually make releases and we version them. So I think I'll just do a short document on how it's just going to be a copy and paste of all the documents that we shared in the chat. Okay. Something I haven't managed to do yet is to harmonize where we keep all the configuration. For Docker, sometimes we're using .env. For some of the services, we're using the config.js. And even in some of the Docker Compose, we're either having some defaults or reading a .env. So I want to harmonize this so it's very clear. There should just be a central place for doing the configuration. Our use case is that you run this in Docker, or you run it as separate services using maybe something called PM2. I don't know if you've heard of PM2, which is to run node services so that they restart if they crash, for example, or if they restart after a server reboot. Okay, so that's what I still have to do. And then I need to update all the documentation. So the solution documentation, how to deploy it. And we also need a development guide. So, you know, would really appreciate anybody who wants to start picking up any of these to-do tasks. Then, of course, we would like some testing. Largely, I haven't changed the solution. So all the code of the health check or managing the API to the front end is just a copy and paste. Nothing, the logic there hasn't really changed. So I'm hoping the testing can be quite light. But with a simplified design, I'm also hoping that more people will start running copies of the monitor. Okay, and then we want to do more workers and more checks. At the moment, I think, Paolo, your alert framework actually does more checks than what we're checking for. So let's see what we can do between the alert framework and actually doing the checks. Should we be doing the checks that we're doing in the alert framework actually as checks, and then the alert just alerts for it or whatever? So there's an opportunity to add more workers and more checks and do more alerting. Okay, and what I had hoped to get into this release, but frankly I've just not managed to get it, is to allow each person who's running a monitor to have a signature. So in the config.json or somewhere, we would have, I don't know, a wallet address, and then we implement at the front end that an operator can chill either a whole member and all their services or one or two services at a time, because we have found, for example, when Milos's servers were down, the monitor just kept on reporting errors all the time. And what we want to do is we want to stop that and allow the member to chill the whole membership or to chill one service at a time. And I think the best way to do that is to create a signed message using a front end. It's kind of like an extrinsic. And that will allow us to have better granular control so that we can not report errors when we know that there's no sense in even running the tests. We need to talk about this because it will take a bit of work, maybe a week. And if we think it's clever to already invest that time, or should we just draw a line under the whole JavaScript era and go for our parachain, or go for at least our solo chain? Okay, conscious of the fact that you might have to go, Kutsal, do you have any questions? Because I'm just going to do a code walkthrough now.
Sorry, Derek, thanks very much. It's brilliant. Yeah, I'll try to wrap my head around the code later on. I'll watch the recording first.
Yeah.
The only thing I can say is I think I can tackle a number of things from the to-do. One is harmonizing the configuration, and I can do some documentation, I think. And I would be interested in testing as well. And I agree with you that I think we should draw the line and leave the extrinsic to the chain.
Right.
I think that's more like a blockchain thing, and I think the members should go there and submit the extrinsics. Then we should watch the events and catch the events and make necessary changes in the alerting and the monitoring, etc. That's everything I can say, and I think it will be better when I look into the code and actually play with it. The code is on the branch now, I guess, right?
Not yet. I was waiting to do the release management because I don't want to mess things up. So once we've sorted that out. Okay.
I think Paulo suggested Git flow. I'm comfortable with that, but anything else I'm good to. Yeah, just let me know what we're following, and I'll conform.
All right. Cool.
Okay. Thanks a lot, guys. I apologize again, and yeah, I'll watch the recording back. See you later. Good to see you.
Cheers. Cheers.
Cheers, guys.
Cheers.
Okay, so we'll go through the code, a quick walkthrough, a high-level design, and then depending on time, I guess we can either switch to the release management topic or we can dive deeper into the actual solution. The directory structure for the monitor, I've changed a little bit, and I will refactor this because I think we will drop the workers directory and we will drop the backend direct. No, anyway, so the new solution is currently in this temporary directory just so that I can keep it separate for the moment. So not going to go into the workers. These were just functions that were running in BoolMQ. Okay, and I've pulled them out into it's a cut and paste largely with a slight top and bottom change for the API service. I've pulled them out to be workers that are standalone. Okay, so let's just go through the worker.js. It is really simple. It imports its own capabilities. Okay, and then it imports the config. And this function is to respond to the ping that comes from the main server. Okay. And then here is a task to execute the job. And what it does is it just checks to see if the job name is included in its current capabilities. If the job name isn't included, then of course it's not supported, and it will do an error callback. And then what it will do is it will try to run the job, and this is a call to run the job. And then if it gets the result, it will call back, and in the callback pattern that we've used, you see in some other solutions as well, the callback is always error and result. Okay, so if error is null, then the result is okay. Otherwise, if you're calling back, you'll send back error and the result is null. So those are the two ways. And here you also call back with an error and null if there's an error. That's just it. Logging, and this is the retry loop. I need to parameterize that because that's not going to, that needs to come from config. Good point. Okay, so this is literally just a socket.io connection. And what it does is it makes a connection. And when it sends the connection, I don't know if you guys have worked with socket before. Normally you just make, you don't include the metadata, but it turns out that in the metadata, you can send query. And in the query, you can send any parameters you want. And then when on the server side, when the socket connection is detected, you can read the query out. And that's where during the connection process, you can set the worker ID and you can set an API key. Right. And this API key is managed by the monitor operator. And then just lots of socket on, for some logging. And you'll see here Sorry, there's the worker. It's just running away. And then when the socket detects a message called jobs, what it will do is it will, for each job that it finds, it will try to execute the job. And that's it. That really is the simplicity of it. And let's just have a look at the config.js. In here, okay. So I need to put the server URL there. So what we can do is we can put a worker ID, and here I've just put some any text. All right, that's the API key that I need to connect to the backend, to the monitor. And here are my capabilities. So you can see I can do a ping, I can do a check service, but I've commented out the check boot node in this case. So whenever we want to run the check boot node test, this particular worker doesn't have that capability. Okay. I'm not currently using this, so that's not important. And then the binder will binary directory for where we're going to find all the executables that are needed for these capabilities. Okay, that's it. Seriously, that's as hard as it gets. And then these check service is just a copy from the previous solution. There's nothing else that's changed here except that the signature is now slightly different because it's not a Bull MQ job anymore. It just runs by itself. So it doesn't have all of the things that Bull MQ provides. So you have to inject them as the context in order for the job to run. So it's the same thing. And here is the check boot node. And the check boot node runs the node itself as a temporary node, and it attempts to start synchronizing. And there's a timing for that. I think it's 30 or 15 seconds. I can't remember if there's a default timing in here. But yeah, I'll go through this later if anybody wants to see how we're implementing the check of the boot node. So that's the design of the worker. And the front end design hasn't really changed. It still does a single page app based on Vuetify, and it calls back to the API. The API, which used to run separately here, I'll get rid of that because the API now will be served from within the Nest.js app. So I guess this will just become front end or server or whatever we want to call it. Okay. The structure of this is that you have a source directory, and then you also have some other config sort of stuff here. You have tsconfig, which I had to hack a little bit. And you have the package.json. The only thing that I've done differently is instead of this being common.js, I've said type is module. Without that, the libraries that are provided by Polkadot and Substrate, they are compiled in ES6 format, and you can't use them in a CommonJS project. So I've had to change this to be type equals module. And that allows us to include all of these guys here, which are used for Gossip Protocol and libp2p. I need to take out that bull. And also this libp2p here. Okay, so that's what I've changed here. And then you'll see sprinkled throughout the code, you will see the fact that I will do includes, that even though this is TypeScript, oh, that was something that Kutzal pity he's dropped now, but it's something that he requested really early on. He said, could we write all of our stuff in TypeScript? Because it really helps. So now I'll put that in the challenges. Okay. So now it is a TypeScript project. But what you'll find is that the imports, where you are importing something that we have written, you import the JS rather than the TS. Okay, that's just a quirk of working with ES6 modules in the Node.js TypeScript project. Right, let's go into the design of the actual app then. So here we have modules. I haven't populated those yet. I still need to build those. Start with, where's the models? All of the models are here. So this is the database structure, essentially, and the relationship between the models. They've been slightly rewritten. It's exactly the same code as what it used to be. It's just been slightly rewritten using decorators and conforming to the having everything within a module or within a class. Okay. So if you're familiar with the database structure and the database objects or the models, then this will be 100% familiar to you. If you don't know, you should know that we are using Sequelize, which is an abstraction layer to the database. So although we are building on MariaDB, you can pull that out and put it in another database that's supported by Sequelize, and you shouldn't have any trouble doing that. Okay, so that's where the models are. They're all in one directory. And then what we'll do is just go through the small implementation of when you hit the home page, there is an API call. I'll just go there. When you hit the home page, right, there is a call to the home service. There it is. Okay, and the home service you will find at /API/home. So there is a configuration in the app which says set global prefix to be API. That means all controllers will listen at /API. That's where you will see all your controllers. Without this, they would listen and the slash, which is not what we want, because the reason why we have shifted all of the controllers to a subdirectory is because just above here, not here in the module itself, we are serving static content, and we want the static content to be at the slash at the root directory of the service. So the static content will be here at slash. That's where you get the static content, and the controllers you will get at /API. Okay. Let's keep on going with the code. So this is the main starting up of the app, and it will I haven't implemented this completely yet, but what I would like to do is I'd like to be able to run 2 or 3 copies of the monitor in a development environment to see if they talk to each other and to speed things up, because I don't want to wait 5 minutes for the health checks, etc. So I'm thinking about how to run the program, but with 3 different config files. So that means that we need to specify the config file, for example, in command line, the same way as you might do other tests. This is not implemented yet. Just go back to the to-do. Put that on the to-do.
Which 3 config files?
So what's the question?
What 3? Is it 3 config files?
So I want to be able to run 3 nodes separately. And when a node starts up, it uses it generates a peer ID. And so if you ran 3 nodes out of the same directory, they would all use the same peer ID, and then you wouldn't get your P2P communication. So
okay.
So otherwise, during development, you then have to somehow copy the directory 3 times and then run 3 nodes. And I'm just thinking, yeah, if only he could spell. Okay, that's on the to-do now. And that I found I've been testing against production, which is the best way to develop, of course. But I found that because I wasn't changing anything with the API, I was able to connect to other monitors that are out there. But if you're actually making a breaking change, you'll have to run 2 or 3 monitors yourself just to make sure that it works. And that's, I think we can implement that by having config files. Anyway, so it literally gets the HTTP port, which is the main HTTP port that's going to be used for the front end as well as for WebSocket connections. And then it runs the server. And that's it. And the app is generated from the nest factory.create and then app module. So app module, I'll just go through these files quickly. And most of these subdirectories have got, well, they all have app module. Some of them have controllers, some of them have services, and some of them have others like a gateway. But they all share this database module. And the database module just follows the pattern of pulling in some providers and sharing them. And the database providers is what you will find. It's a wrapper around Sequelize. So it will provide under this name. So in any of the other modules, if you try to inject using the Sequelize text, then you will get the connection to the database. Okay, and it just sets up a Sequelize instance and shares that. And once you've set up the Sequelize instance, you add all the models, and that's it. That's your database connection. And you can reuse that database connection and call any of these models in the normal Sequelize way. So that's why I think it's really graceful or elegant that using the framework Nest.js, you create something once and then reuse it throughout the rest of the app. So in the app module, so the app service, there's nothing here. I don't think these are used. Moved them to look P2P, so I'll get rid of those. They're not used anymore. Let's go through something quite typical. The front end we have seen does this call to /API/home, and as we know, all the controllers are hosted at /API. And what does it look like? It comes back with some data, and you'll get that data from the home controller. And here, everything is decorated. So here, this class, which is called home controller, is decorated with an @ controller. So the framework knows that it will listen for requests at a certain URL. What's that URL? It will tag on the home. So here, the requests will come from /API/home. That's where the requests will be. And then you will find handlers inside this controller that will deal with anything on this URL. So if you've got HTTP methods, there's a method called HTTP GET. So you can see there's an annotation, and HTTP GET is the decoration on a certain function, and that function will return this signature here. And you should see that that is the same as that signature there. Okay. So that is the pattern for all controllers. You can have a look, for example, in the monitors controller. Here you can see that the monitors controller is decorated with @controller, and that's the path. Okay, and then we have a get, and what that is without any parameters coming in, that's a find all, and the same pattern as that. Here I'm kind of mixing the pattern. I think what we should do is we should probably get this from the service, not directly from the database, but okay. And if you inject or if you send an ID, what that means is it's the same as /API/monitor. And if you were running Express.js app, that's how you would get your ID, or you would get it from /API/monitor/ question mark ID equals 1, for example. That's how you would get the ID parameter. You either get it from this type of URL or you get it like that. And we have specified that that's how you're going to get it. You're going to get it tagged on to the URL. Okay. And then we just, this function name doesn't mean anything. It's just something which is descriptive of what we're trying to do. You inject the request because we need to find the request.params.id. That's what we need to do. And then we get it from the database, which is the monitor. And then we go and get some health checks. We get 50 health checks for a particular monitor. And then we send back date and time format, the monitor details, and the list of health checks. And you see that if you went into monitors, what's going on? Why is this not running? I'll change something. Interesting. I'll have to figure out what that is. Okay, let's just keep on with the code walkthrough. I'll stick with monitors for now. So you can see that there is a monitors controller that literally handles the requests from the front end and sends them. What it should do is it should send them to the monitor service. Okay, the service file is what the API, or sorry, was what the application logic should be built in. And to do that, tours service. Okay. And then if we look in the monitors service, this is where all the functions for dealing with monitors should be handled. And if this module, the whole monitors module, needs access to modules that are outside or functionality that's outside, it should happen in the service layer. So here, the only thing to note really is that in the constructor is where you inject all of the modules that you need. So here we're injecting the libp2p service, and we're also injecting something called the monitors repository, which is a pattern that I started using, but I prefer to use actually Sequelize. Some to-dos. Okay, anyway, it doesn't matter too much. I'll clean it up before I check it in. So get peer ID, get peers, that's to see who we're connected to. So if you look at monitors, what I want to do is obviously we can see the monitors here, but some of them are stale because many of them are development. But also what I'd like to do is I'd like to indicate next to these which ones are currently connected. And we can see that this monitor is currently connected to 2 other monitors. So I think it will be interesting to somehow indicate the ones ending in TAQVU, that one there is currently connected. So maybe some sort of green light or something like that. And this one, wait, GLC, it's that one there is currently connected. And eventually the pruning will take care of these stale monitors. And in the pruning, what we need to do is we can delete a monitor once all of the health checks have been pruned. Because I was just thinking, just delete the monitor if it's stale. And how will we decide if it's stale? But the best way to decide that a monitor is stale is that all of the health checks for that particular monitor have been pruned. Then I think there's no need to keep the monitor anymore, obviously, because it's not been giving us health checks inside of the pruning interval. So just get rid of it. Okay.
How long is the pruning interval?
It starts off at 30 or 90 days. So if you look in the config currently, where did it go? Look in the config. So currently it's 90 days. But that might be too long or it might be too short. The pruning interval really is just here, I think, in case somebody has a dispute about a service to say, well, I think my service is running. And somebody else says, well, I think your service was down. And maybe that affects, if you're an operator in the IBP, it affects whether you got not slashed, but you got some sort of penalty for not running your service correctly. And then you'll be able to come to any of the monitors and say, well, show me some data for the last 3 months. And then we can, that's the sort of record that we're looking for. It's kind of like pruning on a normal node for blocks, because eventually the health checks will be stored in a block. And you should be able to go back to a previous block to see which health checks were submitted in that block. And then we'll have to decide who runs an archive node for the monitor and who runs, a lighter RPC node. Okay. So yeah, where were we now? So that's the monitor's controller. Straightforward. The monitor's service is the application layer. And then there's some boilerplate stuff like the monitor's provider. If another module wants to use, for example, the monitors repository, which is a pattern I'm not using anymore. I'm using Sequelize, so this is a lot less relevant. The same goes for health checks. Let's do the health checks one. It's the same but different. You have a module that module just binds everything together. Okay, need to get rid of that because it's not being used anymore. That. And the health checks module pulls in the service, the controller, and the providers and binds them together as a module. That's the pattern that Nest.js is using. Okay, and then if we look inside the controller, it's the same but different. There's a get without any, and then there's a without any parameters. Then there's a get with an ID. And what it just does is it goes to the health checks service and does a find all, or it goes to the health checks service and does a find one, and you get the health checks here. That's what it's done there. And it's pretty fast because there's nothing else running. You can see it goes pretty quick. Okay, this is local machine, right? But it's pretty quick. So this process is fine inside a controller. The controller hands off to the service. And in the service, you have the same functions. You've got the find all and you've got the find one, but behind them, you can go to the repository. It's the job of the service to implement the application logic. Okay, and it's a copy and paste from the previous solution as to what this looks like and what this looks like and what the pagination looks like. So everything just generally works. Okay. Okay, and then in the provider, it's the same pattern if somebody wants to use the health checks repository in another module. Okay. Let's go to the libp2p, which I think is actually, let's just first go to this new concept, which is called tasks. And these are for short running jobs that are internal and we don't trust any workers to do for us. Okay, and the pattern is the same. We have a module which binds everything together when I'm using event emission. Okay, and you'll see what this module does is it brings in the database module here, imports the database module. So that means the tasks module has access to the database wherever you want it. And it provides the task service as needed. And then if you look inside the tasks service, you'll see, just for those people who can't read cron, I've reminded myself of what a cron looks like. Okay. But you can see all the services are injectable. So that means you can reuse them in other modules. And in the constructor, we're bringing in sequelize. Remember the keyword sequelize? It's provided by the database provider here. See, it's provided by the database provider under a certain keyword. Then if you look in the tasks service, that's coming in like that. And then also event emitter, which I don't know if we're using. Anyway, so the way to run things on a regular basis is to provide one of two things. You either provide an interval, and here you can see that from the config, we're taking the update interval, and that is, the update interval is every 5 minutes, okay? So so every 5 minutes, it will run this task. And that's a task which says create jobs for workers. And that's going to emit an event, which is called create jobs for workers. And then let's just hope that there is a listener for that event. The other way to do this is to pull in the where is it? Not the tasks, the workers module, because in the workers module, in the service, we have it's not in the service, is it in the controller? There should be an event which is listening for that. There should be an event which is listening for that. Somebody should be listening for this. Great jobs for workers. Let's just see where it is. It's there. It's on handle event in the workers gateway. So that's how you link the two together. You can either import the gateway and call the method that you want, or you can raise an event, and on the other side, you can listen for that event. The benefit of using events is that you can have multiple listeners, and each listener will react to the event. But if you want more control, then the best way to do that is to import the functionality that you want into your service and then call the function directly. Okay, so what I'm doing here is raising the event, and I'm raising the event based on an interval, which is every 5 minutes. I'm asking the workers module to call out to all of its workers and create the jobs. I'm also doing other internal housekeeping jobs. Here you can see instead of on an interval, I'm using a cron pattern, and that pattern is every hour on the 1 minute of the hour. Okay, I will read the services.json from GitHub and update the services table. Okay, and then every hour on the hour, so 1 minute before that, I'll read the members.json and update the members. And then at midnight every night, we will run the prune database process. All of these are internal. Of course, you can't ask a worker which is running externally to prune the database for you, because you would never trust them to do that, right? And also you would not trust a worker to go and fetch the members.json or the services.json and insert that into your database. So that's why these are internal tasks. Okay, and we can parameterize these, but it doesn't really matter. I don't want to overcomplicate it. So that's the process for running tasks. Conscious of time, I think I can stay another half hour if you guys want to keep going. If you got any questions for the moment, let me know. Otherwise, I'll just keep going. What I'm going to talk about now is, I'm not going to go into each of these. There was an implementation for 0MQ here, which we've ended up not using. So if anybody wants to see how I did it, I used 0MQ to communicate between the Nest.js application and the libp2p microservice. You can see it took quite a bit of code, but it works. It's really fast, but we're not using it. So it's one less component that we have to worry about. I'm going to go through the libp2p implementation now. And it starts with a module, as you'd expect. And the module imports whatever it needs and then binds it together. But there's a slightly different pattern here, because this is the default way of defining a module. But what's different with this module is that we have configuration that needs to be passed in. So when the configuration is passed in, that configuration is passed in a static function called forRoot. And you can see the options coming in here. And then what happens in the forRoot function is we redefine the defaults. So you see that these look the same, that one up there, and largely similar here. What we do is either redefine or extend the default instantiation of a module. And what we're doing here is we're pushing in the gateway service. The gateway is what handles the technical communication to the P2P network, and the libp2p service is what handles the application logic as to what to do with those messages that have arrived, or receives the notification from our worker to say, please publish this on the gossip network. That's what happens in the service. So let's go through the technical connection first. That happens in the gateway. And in the gateway, we have our peer ID. And this is the peer ID that is read from the keys directory. Is one of the things that I have to consider as to whether we have a peer ID dash development 1 dash development 2. You can have 2 or 3 here to identify which ID to use if you want to spin up 3 copies of a certain of a node just for testing purposes. I'm not sure how to do that. Okay, that server is actually the connection to the P2P network, and then there's just an indicator to say whether it's currently running or not started. Okay, we inject the libp2p options. The libp2p options come from currently config libp2p. I think I did it better in the config.local. I've pushed everything into libp2p. Nope, doesn't look like I've done it properly here. Anyway, we passed the whole, it looks like we passed the whole config thing into the creator in this gateway. So all the config comes in, obviously, because I've not filtered it. So there's just a debugging. Okay, and we push the options that come in into the options parameter or local variable. The reason why we do that is because when we create the P2P servers, we need it to be an async module or function, and you can't have a constructor that's asynchronous. So we just push that into the options, and later on, literally a millisecond later, we have this, which is automatically run by the Nest framework. It's on module init, and you can see it's asynchronous, and then we're off. So we go and look to see if we have a peer ID, and here's, we can parameterize that depending on some sort of config. If the peer ID exists, we get it. If it doesn't exist, we create one. Okay, and then we have our own peer ID. Fantastic. And that's the peer ID that you see here, or you see it there. All right, you see these are the peer IDs of the monitors that are running. Then we work out something called our multi-addresses, and we also work out our announce. This is normal P2P stuff. And then we create the gossip sub layer, which is what allows us to send our messages to all the other monitors using the gossip protocol. Now, the parameters for this has changed. And I think this is no longer used because it's always true. Gossip incoming. Also, the signing of messages used to be set to, you could sign them or not if you were gossiping a message. And now it just seems to be that it's always true or no longer relevant. So that's why if you were looking at the code before and you've seen some of these, you'll see that the signature of this gossip sub has changed. Okay, and then we create the main node, which is libp2p. And inside of libp2p, we listen on a certain address. If you've seen this before, it's basically because that's the multi-address format. We listen on all IP addresses. We announce as well. We only use the TCP transport. And here I've made some changes to the connection manager. The minimum connections by default is 0. So what I've done is I've set the minimum connections to be 3. So if your node is not connected to at least 3 other nodes, this connection manager will keep on redialing, trying to establish connections to other nodes, so to keep the network alive. that was an oversight in the previous implementation. That was never even specified. So it just defaults to 0, which is why you might find sometimes if you're running a node and somebody else shuts down their node and brings it up again, your node doesn't reconnect. So I think 3 is reasonable. You can put this higher if you want. It's not currently in the config. You can make a code change. Okay. And then the way to find your peers is through multiple strategies. I have removed MDNS because that's only valid for your internal network. But we need to think about if this is going to help us when we want to do testing. I don't think so. I think we could still put the bootstrap peers manually. If we've got 3 different test nodes that we want to fire up and we want them to find each other, I think you could manually put in localhost bootstrap peers in the 3 different config files. So I don't think we need MDNS. Okay. So this is the bootstrap peers. There's the list that you get from your config file. And then just some other timeout stuff. This is 3 seconds timeout in order to connect to another peer. I think 3 seconds is enough. We haven't found any problems with this. And previously I had some of these tags put in, but I don't think we need them because we're not using, for example, the time to live, or we're not using any rating, because it's not like we have thousands of peers that connect to us and we have to somehow rate limit them or anything. Okay, this has not changed. And we will not do that because I was going to implement a peer-to-peer, a libp2p connection to the browser as well, because I was thinking the browser, when somebody's actually on our website like this, they could be running a copy of the worker. For example, they could do WebSocket connection to an RPC service to see if it makes a connection and give us the timings. That's not implemented, so maybe that is for a later option. And we start the libp2p server, and by starting the libp2p server, it includes the gossip sub. Okay. And that's it. And then we just have some listeners to say, well, what happens when a peer connects? Well, we will let the service deal with that. What happens when a peer disconnects? We'll also let the service deal with that. What happens when a peer is discovered? A little bit of debugging, but we'll also let the P2P service do a handle peer discovery. And then this is the interesting stuff. When we get a gossip message, what do? We also let the service handle the gossip message. Okay. And then we subscribe to our topics. This is typical P2P stuff. If you look at the config.js, the topics that we are interested in are these. And in fact, that topic is no longer relevant because we're not sharing services between node and node. We're reading them from the services.json. So I'm going to take that out. And I'll also take it out of my config.local. Don't think I put it in here. No. Okay. So that's just our placeholder. I'm not really using that. This is how you get your health check on the gossip protocol. And this is how I'm planning to send a signed message from one node to another. All right. Let's keep going now. That was the actual gateway. Oh, and the last thing is that's not really implemented. The last thing was, how do we actually send a message on the PubSub network? So other services will call this publish function, and that will basically just do on the P2P, on the PubSub, do a publish on a topic, right? So this topic is what relates to the IBP health check. That's how you subscribe to messages on a topic. Any questions so far? Then if we go to the libp2p service, this is not supposed to be the technical layer. As I've said in the comments here, libp2p service handles the application logic between the monitor and the P2P gateway. And the P2P gateway handles the technical connection to the P2P network. Okay, so you'll find it quite simplified here. We had a circular reference between the gateway and the service. So what you'll find is there's a slightly different way of injecting the gateway here. It's injected with this thing called module ref, so it doesn't get injected when the application starts up. It gets injected like milliseconds later, so that you don't get this circular reference of the gateway referring the service referring the gateway. So that's just an interesting pattern that you get here. But what you see is that I'm bringing in Sequelize because this is a service layer or a service component. Here we've got getters and setters for the peer ID. And then need to just make sure that that's working, because the peer ID is supposed to come up at the bottom so that you know if you're connected to a particular peer. It works on these. If you're connected to a particular peer, you know what that peer ID is. And typically, because you're on that peer, you will get a little tick to tell you that whatever's relevant to this peer is identified. So if you look at health checks, for example, you can see that these health checks came from the peer that you're looking at. You would expect other health checks come via the gossip protocol, you see? Okay, so that's just a way of identifying information that came from this particular peer. That's why I'm using the peer ID throughout the app. Okay, and then get peers, that's a new call that gets the list of currently connected peers. And then this publish, so this is the libp2p service, but we've got a publish, and all it is it's a wrapper through to the gateway publish. Okay, same signature, but people should not be calling the gateway directly. They should be coming through the service. Here are the handlers: handle peer discovery, handle peer connect, handle peer disconnect, which are currently just doing debugs. But handle peer discovery is updating or upserting. There's a pattern called upsert. The other monitors. So it's doing this.sequelize.models.monitor upsert, and it's got an ID and some multi-addresses. Multi-addresses are how you would address, how you would make a connection. So there's the connection, the connection, how to send information directly to this peer. Okay. And this is the most important one, is handle pub sub message. So when that comes in, we have a look at the topic. And if it's it would only come in if it's a topic that we've subscribed to. And it will be typically the only one that's really being sent is the health check. And if it's a health check, that means that another monitor has done a health check and is sharing it with a network. So what we will do is we'd create a model, right? And then we would update the monitor to say that its status is active. It might have gone offline for a couple of days, weeks, months, whatever. As soon as it comes back online, we will update the status to be active. I was going to use this for pruning. Maybe we still use it for pruning, not sure. And then some other updates here. You need to be familiar with the data model to understand what the relationship is between members and services, and member services, and member server node. Sorry, member service node. Because remember, some of these services are running behind a load balancer. So when you connect to rpc.ibp.network/Kusama, you will connect to a load balancer, and the load balancer will send it one or two down to server 1 or server 2, however the operator has implemented that. Okay, so what we're doing is we're tracking the node behind that service, and you will see if you look at a member, for example, let's just take $. Here are the nodes. So you can see that for Kusama RPC service, there are 2 separate nodes. Not really using that at the moment, but the requirement is that we do load balance, that we do have, for resilience purposes, that we do have nodes, and we can see when it was last seen, right? 14th of the 5th. So something's not being updated. You would expect the latest health checks came in today. So Kusama RPC, so there's a bug in the code. This is not being updated. So every time this node is observed, we should be updating it here. So this code is obviously not working. So there's a defect if anybody wants to try and have a look at it. I can see that there is a create, but there's no update. So there's a defect, okay? If anybody wants to take that on, what we will then do is we will be able to use this information to see if the operator is actually operating the right number of nodes behind the load balancer. Moving on. Here, what we do is we create the health check record with the details that have come in. And I've started implementing what to do when we receive a signed message. This is where I'm going to allow node operators to chill a service or to chill the whole membership, if that's what they want to do. Bit of a problem with chilling the membership, because it might get overwritten when we read the members.json file from GitHub. So I haven't really thought through how that's going to work. I probably won't implement it because, as you heard Kutsal saying earlier, that I think we need to draw a line under this journey with Node.js and start focusing on what we're going to do, how we're going to run things on chain. So that is all I had prepared for today. While I was reading through something, I thought, let's just look at some other topics, like what does the members.json and the services.json look like, but also what can we do for release management. I think now is probably a good time to break for questions, if you guys have any.
Yeah, hi there. Yeah, so there's a few changes, so I need to double check. Eventually, just running this locally to see how does this look like. But the part that I'm more interested most is, for example, the way how I'm doing it now is that I'm using the Boolean queue to publish the alerts. And then I have a worker that it's just reading if there's an alert to be sent. And what that worker does is, okay, if there's an alert on this queue, so I'll just post this alert to a remote endpoint. Yeah. So what I'm interested most is how I will switch that into this kind of pub sub that you have implemented here now. So after the health check has been saved, eventually I will just, exactly like I'm doing now, just run some kind of rules. I will publish the alerts into a different queue, potentially a new one that you have shown me there. And then I have a kind of a different worker that will just read from that queue and then publish to a remote endpoint.
Yeah. To be honest, it's something I didn't consider, and I apologize. So let's just have a look at the current design of the workers. The current design of the worker is that it has a very straightforward list of capabilities. And the capabilities are stuff that we want the worker to do. So I'm not sure it's relevant to think of a worker scenario to run the alerts, because I'm not we should. So I'm just going through the terminology, right? So with workers, but what we want to do is we want to somehow get you the event that you need to make.
So the thing is, immediately after the health check has been run and has been stored on the database, I will run some rules. Yeah. So, and after those rules, or either I will we can eventually just post this to a kind of a pub sub that will be processed later, or I can publish to a remote endpoint if one of those rules has been triggered. Yeah. So for now, eventually, for the simplest way, eventually now I will just run some rule. If one of the rules has been triggered, I will just, rather than just creating a new pub sub, I will just publish that message to the remote endpoint. It doesn't matter. So the pub sub here could be kind of irrelevant. So eventually I'll just need to find out now where are you storing the health check on the database, and eventually where I can run those rules after the health check, or either will be in a kind of a new service, or eventually immediately after the health check has been stored. I don't know. Just something easier for now. I think that's probably the best.
Yeah, I'm trying to think, because it will be quite. It's not like it's going to run every 5 minutes, just once every 5 minutes. Let's just say we've got.
No, every time a health check has been stored, it should run the rules.
Yes, but I'm just trying to think, how do we get the health check to you? You'll be running your own copy of the monitor.
Yeah.
And how do we put in? So I think the way that it works then is to have another module here, which is called alerts. And we configure the alert endpoint to be a queue. And if the alert endpoint is not configured, then it's just not configured for all of us, but you would configure it to be a bull MQ. So I can put a bull MQ module.
But I don't really need to use the bull MQ, you know. So the bull MQ is just it's a nice solution, but to be honest, I can skip that bull MQ. Because on the alert system itself, it's a completely different project, and what it has, it's just a kind of a endpoint that it's receiving post requests. So every time I post an alert to that endpoint, it will just trigger the alert to the matrix room. The bull MQ is being used at in my monitor, but it's inside this Node.js. So you have refactor all these. So potentially I will not use bullMQ anymore, you know. But right. the rules engine itself, potentially it will be exactly the same. Because what it does is just, it picks up on the last health check that has been done and has been stored on the database. Eventually to pull out the previous health check for that member and from that service, it will just double check some conditions, and if one of those conditions is false, it is true, it will I can just post immediately to the remote endpoint, that it will then just send the alert to the rooms.
But the functionality that you are describing means that the alert engine needs access to the database.
Yes.
Yeah. So it's that. What I'm thinking about, where does it sit? Does it sit outside as a worker, or does it sit sort of inside where it only needs read access to the database? So it could be through API. It could be, we implement an API to search so that you don't need to have database access. Then you can actually run it as a worker. But I'm off the top of my head. Sorry, did you say which queuing mechanism you want to use if it's not going to be bullMQ? Which
No,
pub sub would you use?
yeah, I was just trying to think out loud, because you for what I could notice is that you have implemented the pub sub, a new pub sub inside the lib P2P framework. I believe that's for what I could see, at least. So
Yeah,
you have some kind of subscription from topics, and then I can subscribe to a new kind of alerts topic, and then there is a worker that will just listen to that topic, and then it will just publish more or less what we have on the bullet queue. And I'm just trying to understand if that will make sense, or if it's worth the travel, or if it will just I will just run the rules engine immediately after where we are storing the health check, because it'd probably be easier.
So
The
challenge,
problem,
yeah. So I'm trying to think of, from a component architecture perspective, if you implemented something like this, right, where you are actually listening to, let's call it the chain. We know it's not a chain, but where you are listening to the chain for the event, and when you get an event, which is you'll get it like this. You will get from libp2p, because it's built into libp2p. There's a module called pub-sub, and you get an event, and that event is like, it's a message, okay? And if you have a look inside that EV, you'll see that in the event.detail.topic, there is the topic that it's on, and typically this is /IBP/health check, right? You could listen for these.
okay.
We could create you a small implementation that just has the libp2p module, and it listens for these messages. We could create a really small implementation. So basically, you have exactly this libp2p gateway, and you have the libp2p service, and you have here your code would be in case it's P2P health check, then you run your alert logic.
Rule. Yeah, exactly. That's
the challenge that I'm trying to think about is that in your alert logic, you need to go back to the database. So that means in this, you also need a database connection, which I've got because I'm injecting SQLize here. So the question is, do we build it as part of the monitor? You know, do we just take your logic and put it in here, or do we extract 2 or 3 components from the whole design here and just create you a service that you run? But your service will you'll have 2 connections to the database. You will have the monitor connected to the MySQL or the MariaDB database, but you'll also have your alert framework connected to the same database, because you have to reach back in time to look at the differences, right?
Yeah.
So I think, yeah. And then when you've done the analysis, or you've done the checks to see whether you should raise an alert or not, we then have to look at the other side, is where do you push it?
Yeah.
Do you have an API that you push it to, or have you implemented it yourself?
No. Yeah, I have an API that I can push it to. So it's just kind of an endpoint.
So then it makes sense to actually to duplicate what I've done here, so that we're roughly on the same platform, where you just take a very cut down version of this source directory, and you just take the libp2p, and I don't know if you want to build a homepage for it or something like that, if you want to monitor it, but you can just run it as with a libp2p and another gateway, for example, for connecting.
No. I think it should be live inside the same system. Eventually, what we can do is there are monitors that are running the alerts, has a flag in the config file, for example, and there are other monitors that don't really need to run the alerts, you know, and that's how I am doing it. For example, when I'm running the monitor locally, I just created a new Docker Compose file, which has the additional Docker services that are needed to run the alerts, you know. So I think it's probably easier just to put, rather than for me to copy this the whole thing of the libp2p and just kind of create a kind of a different new system, you know. So eventually what I will do is just look at what you did here in the P2P, see how you are actually using this pub sub, and then just replicate the same.
So you can look for this, right? You can look to see in the config if there's something for alerts.
Yeah, or either on that allow topics. Can we not just create another different allow topic? That's what I'm trying to think of. I need to really to go through this a little bit carefully, but I'm just thinking out loud.
Yeah. So this is so that's no longer working. This is going on the P2P network. These allowed topics. And this is what we will receive. And are you saying that perhaps we want to send to all monitors? We want to send an IBP/alert like that.
Yeah, no, that does not make sense. No, what I will need is just a listener for the IBP health check. So as soon as the health check has been stored, it will publish an event, and I will listen to that event. And as soon as I receive that event, I will run the rules, and I will just post the message to the remote endpoint. So I think the simplest way to be doing like this.
Something like that. I don't know. Not localhost, but you know your.
Yeah, currently now is localhost. It's just a different service that is running in a different Docker container.
Wherever it goes, and then your version of the monitor will make this, I don't know, true, for example, because maybe you need to protect this with an API key.
It's already protected, yeah.
Yeah. Something like that. And then because we don't have it, we will keep this false, but you put this to be true. And then there's a module in here that uses the alerts config and pushes the alerts to Magix.
So, but how do I listen to this new health checks? I'm intrigued.
I will show you how to do that. We can do that on a breakout session. Or do you guys want to stay for that now?
I can actually. I will have to leave in 10 minutes, so I don't really have that much time. So, yeah. or we eventually you can just put this in a different branch or whatever, that we can just run this, push this to run it locally, because you have already this is up and running, isn't it? Or not?
Well, it's up and running on my dev machine, but as you can see, as I've been talking, I made a lot of changes, so it needs a bit of cleaning up. So before I go and actually make a release, I'm going to publish a combination of the documents that you shared and what I found, so that we will have a release management process. And then I'm going to follow this release management process to get to 0.2. And then well, probably not refactor. And then maybe we'll have to refactor this before we get to 0.2. So I'm going to release 0.1 as a release, so that we've got it snapshotted in a release, and then in the head, we will continue on our way to 0.2, and that's when we can include the alert framework. Yeah.
Okay. Well, whatever suits you best.
Yeah, no, it's not me, guys. I mean, as much as I've put blood, sweat, and tears into this, I'm hoping that we're all going to be equally involved, because we have to put our arms around this, right? Otherwise, it's just always me. And then I need to spend an hour or two just reworking this, because I know Kutsal has got some ideas about how to make sure that we only do config in one place, even though we're using it potentially for different purposes, or we want to run it. Some people don't like Docker. Some people want to run it on the bare metal.
No, but to be honest, I think we don't really need to complicate on this. We are just 2 or 3, 4 guys. Potentially, if we all run this Docker with a kind of a new, a nice instructions on how to run it, everyone can run it. You know, it's just follow those commands. You can just, that's it. We don't really need to complicate on here and expect that everyone will just run their own solution. I think that's no need for that. So this is the Docker Compose files. They are pretty much clean and clear. So I think if we just stick to that and then tell everyone to run the monitor like this, everyone will just follow those commands and that's it.
Cool. Right. That's all I've got. I'll say that's all I've got. That's where we are right now. And
okay, so I'll stand by in the meantime, waiting for the for some code from your side to be published, and then after that I'll just see how it will best, how can will best refactor my site.
Yeah.
Yeah.
I think it's just the three of us. Tommy, any questions?
No. Is the code available anywhere right now? It's not any development branch.
Not yet. No, that's right. Because at the moment, if I lose my laptop, I lose 2 weeks of my life or 3 weeks of my life because one. So yeah, I want to get this snapshotted. As Linus Torvalds once said, I don't make backups. The rest of the world just forks my code. So yeah, so I want to get it into a release so that at least it's safeguarded and you guys can start, we can start getting the momentum going where we build more stuff.
Yeah.
Cool. And I will publish that. Where are we now? It's 3 o'clock my time, and I have a couple of school runs to do for the kids today. Yeah, maybe end of tomorrow, hopefully, I will get the release management stuff out of the way, and then you guys can start seeing the code and contributing.
Yeah.
All good?
Yeah,
excellent.
all good.
Yeah, thank you very much.
Okay, thanks for the
All right,
session.
guys. See you online later. Cheers.
See you. Bye.
Bye.